Very good morning, my dear students. Last class we were discussing about resource allocation graph. One thing you keep in mind while drawing this graph is that whenever there is a request edge, that is the edge going from the process to resource, you will be drawing the arrow from the circle of the process to the outer part of the rectangle. Don't make it go inside the rectangle, just let it touch the rectangle at one of its sides. Why? This is because in a particular resource, we know that it could have multiple instances. So, a process is requesting for a resource, we don't know which of the instances of resource will be assigned to that particular process. So, don't make this request edge arrow point up to the dot, but only make it point up to the rectangle. But when you are making an assignment edge, always make sure that the arrow from the dot and goes to the process circle. If you look at this R2, resource R2, there are two instances. We see first instance is going to P2 and the second to P1. So, this is how a resource allocation graph looks like. So, how do we find out if there is deadlock in a system using the resource allocation graph? So, the first and foremost thing you need to remember is that if there is a deadlock, then the resource allocation graph you will be able to find a cycle in the graph. So, what do you mean by cycle and how can we identify a cycle? So, the cycle is something like you start from a particular process and then you follow the arrow. If the arrow lead you back to the same place or the same process you are started, then this is called a cycle. For example, here you see that P1 goes to R1 and R1 is going to P2 and from P2 it is going to R3 and R3 it is coming to P3 and P3 is not going anywhere. So here we cannot say there is a cycle. There is no cycle here. So in this particular resource allocation graph, we can say that there is no deadlock occur. But if there is a cycle, there is a chance that there will be a deadlock. And again, keep in mind that if there is a cycle, it does not necessarily mean that there will be a deadlock for sure. But there can be a possibility that there can be a deadlock. So just having cycle is not a sufficient condition for deadlock, but it is a necessary condition for deadlock. That means if there is a deadlock for sure, there will be a cycle for sure. Here is an example. We have the same example above but added one more edge here. So at this point, two minimal cycle exist in the system. So if we started from P1, P1 is going to R1 and from R1 it comes to P2 and from P2 it is going to R3 and R3 it is going to P3 and P3 is going to R2 and R2 is going back to P1. So we come back where we started. So that what we mean by a cycle. So also if we start from P2 and the arrow is going to R3, R3 to P3 and P3 to R2 and coming back to P2. So we started from P2 and we ended at P2 again. Now we can say P1, P2 and P3 are deadlocked. How? We see that the process are waiting for the resources are being held by other process and nobody is going to release the resource because they are waiting to acquire other resources. So this cycle is not going to break and they are going to stuck in this cycle. Hence we say that the process P1, P2 and P3 are deadlocked. So this is how you can identify with a deadlock will be occurring in the system using the resource allocation graph. Now let us take another example. Here we have 4 processes P1, P2, P3 and P4 and 2 resources R1 and R2. R1 and R2 is having 2 instances. In this example also we can see a cycle. P1 is waiting for R1 and R1 is being held by P3 and P3 is waiting for resource R2 and R2 in turn is being held by P1. So we see that we started from P1 and ended back at P1. So there is a cycle. However, here is no deadlock here. Why? Here process P4 may release its instance of resource type R2. That resource can be allocated to P3 and we can break the cycle. Once P4 completes its execution, it is going to release R2. Once it releases R2, R2 can be assigned to P3. Hence no cycle after that. There is a cycle but there is no deadlock. That is why I said that if when there is a cycle, it is not sure that there will be a deadlock. But there is a possibility that there is a deadlock. So, a cycle is a necessary condition for a deadlock. That means if there is a deadlock, there will be a cycle for sure. But it is not a sufficient condition. If there is a single instance for resources and there is a cycle, then there will be deadlock for sure. So this is how you can analyze and identify deadlock with resource allocation graph. So hope this is clear to you and thank you.